Good evening, my YouTube viewers. It is Crystal here, and I'm just here this evening because I want to give you a code review on how to use a convolutional neural network to classify images of the Tamil language. So the first thing we'll do is we'll talk about the Tamil language, and it's a Dravidian language natively spoken by the Tamil people of South Asia. Tamil is an official language of the Indian state of Tamil Nadu, the sovereign nations of Sri Lanka and Singapore, and the Indian Union territory of Puducherry. So we won't talk any more about that, but if you want to know more about the Tamil language, you can look it up on Wikipedia and you can read all about it. It's because mainly what we are concerned about is the convolutional neural network that's going to be used to classify the images in the Tamil language. So according to Wikipedia, a convolutional neural network is a regularized type of feed-forward neural network that learns feature engineering by itself via filters or kernel optimization. Vanishing gradients and exploding gradients seen during backpropagation in earlier neural networks are prevented by using regularized weights over fewer connections. For example, for each neuron in the fully connected layer, 10,000 weights would be required for processing an image 100 times 100 pixels. However, applying cascaded convolution or cross-correlation kernels, only 25 neurons are required to process 5 by 5 size tiles. Higher layer features are extracted from the wider context windows compared to lower layer features. And so there's more information about convolutional neural networks, and you can read all about it in Wikipedia if you like. So what we're going to do now is there's a Kaggle competition called Tamil Handwritten Character Recognition, and basically you're supposed to classify the characters in the language, and there are, I believe, 156 or 158 actual characters. 156. There's 156 actual characters that you have to classify. Now, what I did is I don't have a lot of experience in convolutional neural networks. I don't have a lot of experience processing images. And so the people who actually made this competition invited the contestants to show their work. And because they invited the contestants to show their work, I was able to look at somebody else's work to try to solve the problem. And I knew that I wanted to use a convolutional neural network. I didn't want to use a transformer. And so there was actually somebody who had used a convolutional neural network. So I borrowed some of this person's code, which you're allowed to do. You're allowed to make your code public, and if you make your code public, the idea is that other people can look at that code and try to improve on it. But basically, so I used this person's code, and I got a score of 0. Don't ask me how I got a score of 0, but I did. And I went and looked on the leaderboard, and when I looked on the leaderboard, all of the scores were 0. So I'm not sure exactly what is going on. I don't know if they're closer to the completion date, if they are going to make the real scores, but everybody got a score of 0. And so I really contemplated about doing a code review on this because I got a score of 0. But I thought about it and I thought, well, there's not anything really wrong with the code per se. If it is actually in fact 0, then the problem is that they had 156 images to classify, and maybe that was just too many images for this problem. So I decided I will go ahead and do the code review because the code is good code. There's the possibility it's got too many classifications. So what I did was I wrote the code in Kaggle's free online Jupyter notebook, and what I will do, I will leave a link to the Jupyter notebook in the description box down below. So if you want to look at the code, you can, because you can use the code in other contexts if you want to, and there's nothing wrong with the code. And the neat thing about this is it's not a transformer, because a lot of people are using transformers these days. And the thing about transformers is that if you want to enter a Kaggle competition, you have to turn the internet off. And in order to get a transformer, it's not going to work if your internet is turned off. Or that's been my experience anyway. A transformer will work with the internet off on PyTorch, but it won't work with the internet off on Tensorflow. Now that's my personal experience. If somebody is able to get it to work with the internet off in Tensorflow, then certainly let me know. So after we created the notebook, we're going to do the problem statement. So the problem statement is classify images in the Tamil language. So the first thing we want to do is we want to import the libraries that we're going to use. And the way you're supposed to do it when you're writing programs in Python is you're supposed to import all of the libraries at the beginning of the program. And so I did it that way on this instance. So we're going to import NumPy as NP. That creates your NumPy arrays and performs numerical computations. We're going to import pandas as PD, which creates your data frames and your series and processes the data. We're going to import OS, which goes into the operating system and retrieves the files. We're going to import PIL, which is an image processing library. We're going to import TensorFlow, which creates your neural network. From TensorFlow, we're going to import Keras. Keras is a sub-library within TensorFlow to create the neural network. From TensorFlow.keras, we're going to import layers. From TensorFlow.keras.utils, we're going to import image dataset from directory. We're going to import from TensorFlow.keras import callbacks. That's useful in your when you train the model. We're going to import matplotlib.pyplot.splt. That enables you to visualize the data, and then we're going to import warnings so we don't have to see the warnings. So we wanted to see what version of TensorFlow we had, and we're using version 2.12. It's always a good idea to know what version of TensorFlow you're working on, and the reason why is because it goes through so many changes. And it goes through so many changes that some code you're working on may in fact be deprecated. We're going to set the seed. So we're going to set the seed on TensorFlow, and then we're also going to set the seed on NumPy. So tf.random.setSeed42, np.random.seed is 42. We're going to set the matplotlib defaults. So plc.rc figure auto layout equals true, plt.rc axis, label weight equals bold, label size equals large, title weight equals bold, title size equals 18, title pad equals 10, plt.rt image, CMAC magma, and then warnings, filter warnings, ignore. So that means we're going to ignore the warnings. We're going to load the data sets from the OS file. So train equals read pd.read.csv, and then Kaggle train CSV. Test is exactly the same, except for you're using the test.csv. You look at train info, so you're going to have one column which is your ID column, and you're going to have another column which is your class label. So the ID column is an object and the class label is an integer. So we look at train, so the ID is their 1.bmp all the way down to 62870.bmp, and then it's got the class label assigned to it as well. So we call that test, and you can see test is the same, 1.bmp all the way down to 28080 bmp. So we're going to analyze the images. So width height equals image.open, Kaggle input timr hwcr, train Kaggle.1.bmt, and then your size, and you print your width and your height. So your width is 64 pixels by 64 pixels. So now what we're going to do is we're going to visualize 5 of the images in the Tamil language. So examples equals 5. For index and range examples, image file equals train ID index, image path equals os.path.join, and then the Kaggle path, and then image file, img equals image.open, image path, and then you're going to visualize it. plt.figure, pig size equals 2, plt.imshow image, img, plt.title, fimage, image file, plt.axis off, and plt.show. So we've got 5 images from the Tamil language. So we've got 1, 2, 3, 4, 5. Now what we're going to do is we're going to define the label. Label equals class label. So you're going to do print train label.in unique, and that's 156. So that tells you that you've got 156 classes that you have to classify in this problem. So we're going to describe it. So you've got your count, 62870 in the train file. You've got your mean, your STD, your min, 25%, 50%, 75% max. And now what we're going to do is we're going to create a histogram. But instead of using Seaborn, which is what I normally use, we're going to use Matplotlib. So plt.hist, train label, comma, bins equals 50, comma, color equals blue, comma, edge color equals black. And then now plt.xlabel is character, plt.ylabel is frequency, plt.title is histogram of characters. So this is the histogram that was created using Matplotlib. And you can see here we've got 156 characters. So now what we're going to do is we're going to construct the data image train directory equals Kaggle input Tamil hwcr train Kaggle. And image test directory is exactly the same except you're using test instead of train. Now we're going to sort the values. So train equals train.sort values by ID, and test equals test.sort values by ID. So now what we're going to do is the we're going to do some more work on this. So train labels equals train label to list. So that means you're putting it in a list. Train DS val DS equals image data set from directory. That's a TensorFlow function. And then it's image train directory, labels equals train labels, label mode equals int, validation split equals 0.2, subset equals both, seed equals 42, image size equals 64 by 64, batch size equals 32. And then test DS equals image dataset from directory, image test directory, labels equals none, label mode equals none, image size equals 64 by 64. So you can see they found 62,870 files belonging to 156 classes. 50296 files are for training, 12574 files are for validation, and they found 228080 files belonging to one class, and I think that was in test. That was your test. But the one class, it didn't have a label, so I don't know how it says one class because it didn't have a label, but there you go. Now we're going to construct the data set. So autotune equals tf.data autotune. Train ds equals train ds.cache. Shuffle 1000 prefetch. Buffer size equals autotune. Val ds equals val ds cache. Prefetch. Buffer size equals autotune. And then you're going to build the model. So we're going to build a sequential model. It says layers.rescaling 1/255. Input width equals width height 3. And the 3 means it's a 3-color channel, even though it's in black and white. And I looked on the TensorFlow documentation, and that's what the TensorFlow documentation says, is to use 1/255, because what you're doing is you're normalizing the images. I rather would have used the normalization formula, but this is what TensorFlow says to do, and I couldn't find in my research any way to normalize it any other way. So we're building the convolutional block. Layers.conv2d, filters equals 16, kernel size equals 3, activation equals reload, padding equals same. Layers max pull 2d, layers dropout 0.25. Then you have a convolutional layer block 2, layers equals convolutional 2d, filters equals 32, kernel size equals 2, activation equals reload, padding equals same, layers.max pull 2d, layers.dropout 0.25. We do convolutional block 3, layers equals CLNV 2d, filters equals 64, kernel size equals 2, activation equals reload, padding equals same, layers equals max pull 2d, layers dropout equals 0.25. And now we do the classifier head. Layers.flatten, layers.dense, units equals 256, activation equals reload, layers.dropout 0.50, layers.dense, units equals 156, activation equals softmax. So 156 is the number of unique unique values in the label. So if you had wanted to say layers equals, if you had defined something like num class and then make the 156 the num class, you could do that, but that's what we did. Activation equals softmax. Softmax is when you have a classification problem that is more classes than 2. Now we're going to compile the model. model.compile optimizer equals atom, loss equals tf.keras.losses sparse categorical cross entropy, from logits equals true, metrics equals accuracy, and model equals summary. So you can see a summary of the model. Now we're going to train the data into the model. Early stopping equals callbacks.early stopping, monitor equals valve loss, min delta equals 0.01, patience equals 3, restore best weights equals true. And then you say history equals model.fit, train ds, comma, validation data equals val ds, epochs equals 20, verbose equals 1, callbacks equals early stopping. So we run it for 20 epochs. So we run it for 20 epochs. And then what we're going to do now is we're going to use matplotlib to plot the loss and the accuracy. So you can see here we've got the loss in the blue and green and accuracy in the red and amber. So if I had run it for more epochs, like maybe 30 epochs, then possibly I would have gotten a higher level of accuracy. But I had an accuracy of 95% when I had only 20 epochs. But I could, if I wanted to, I could set it up for 30 epochs and then I would get higher accuracy. Because you can see here on the graph that the accuracy is slowly increasing as we increase the epochs, and the loss is slowly decreasing as you increase the epochs. So now what we do is predict on the test set. Predictions equals model.predict test set. So you can see your predictions here. Softmax predictions equals NPR max. Predictions axis equals 1. And then we prepare our submissions. Submissions equals PD data frame, ID, colon, test ID, comma, class label, colon, softmax predictions. Submission.toCSV is submission.csv, index equals false. Submission equal read pd.readCSV submission. And then you can see the class labels, what I had predicted them on the on the test set. The only thing that I could have possibly have done was to increase the epochs to 30. And then when you increase the epochs to 30, then that would have potentially improved the accuracy. That's one thing that I could have done. But with regard to me getting a 0 accuracy, well, everybody got a 0 accuracy, and I suspect it was to do with something to do with the organizers of the competition. But at least they made their code available. They said that people can make their code available. And then when they did that, it made it so I could see the code. I could see how to make a convolutional neural network. And you can use this code in other in other competitions, other problems, because it's good code. So I'm going to go ahead and close this video for now, because we've talked about everything that we could talk about in this competition question. And so I'd like to thank the person who made this code available for me to look at it and use it. And I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And if you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And thank you again for watching my video. And thank you to my subscribers for supporting my channel.